Alright, now before we talk about reactions that involve the oxidation of alcohols, let's kind of clear up how this is a little bit of a misnomer. When we say we are oxidizing alcohols, that's not really true. We're oxidizing alcohol molecules, but specifically we're oxidizing the carbon that is attached to the alcohol functional group. So here I've created four scenarios for it. The first is just a terminal methyl group. Now if we were to look at the oxidation state, the actual charge of carbon, assuming that all bonds here were purely ionic, we would see carbon here is in a -3 oxidation state. Now, let's say we switch that methyl group to an alcohol. How does that change the oxidation state? Well, in this case, we end up going to a -1. Because what we end up doing is we end up losing a hydrogen, which would give its electron to carbon, and we end up giving it an oxygen, which takes an electron away. So we end up losing 2 in the process. Next option is that we go to an aldehyde. In the case of the aldehyde, we end up with a +1 oxidation state. We've removed another hydrogen, so that takes an electron away from carbon, and we've got another oxygen, which takes a subsequent electron away from carbon. And our last extreme here is carboxylic acid. So here we have oxygen in a +3 oxidation state. So when we say we are oxidizing alcohols, what we are saying is that we are taking carbon that's attached to the oxygen from a -1 oxidation state either to a +1 or a +3. We're basically increasing the number of carbon-oxygen bonds that are present in the molecule relative to what they were starting with the alcohol. Now, the subsequent reactions here, we're going to look at extremes. We've got some compounds that go completely to this +3 oxidation state, and we've got some that are general enough to only take us to the +1, and then we have several cases where it doesn't matter what we do, we're only going to go to a certain oxidation state. But this is the framework for how we're going to talk about oxidation of alcohols.